for you. An engineer could simply type, "Create a sequence diagram for a user purchasing a product." Client API Gateway Order Service Payment Service. Within moments, the AI produces a visual flowchart the team can immediately share for feedback, turning hours of diagramming into a 2-minute task. This creative augmentation extends to writing code itself. Faced with a novel problem, engineers often spend significant time exploring algorithmic approaches. AI can be an interactive brainstorming partner, suggesting alternatives and ways to optimize existing solutions. If you're struggling with an inefficient data processing loop, describe it to an AI and ask for more performant alternatives. It might suggest refactoring an ON2 algorithm into ON-log-N, recommend a different data structure, and provide a complete code snippet to demonstrate the concept. The final dimension of AI-driven efficiency is its ability to act as a personalized, on-demand learning engine. The pace of technological change is relentless, and engineers must constantly learn new frameworks, libraries, APIs. This traditionally involves sifting through dense documentation, long tutorials, scattered forum posts. AI can compress this learning curve dramatically by providing synthesized, context-aware answers. Instead of reading a 50-page guide on a new cloud service, you can ask the AI, "What are the 5 essential steps to deploy a Node.js application using this service?" and provide a minimal configuration file. You get a direct, actionable summary, saving hours of research. This accelerated learning is particularly effective when troubleshooting unfamiliar territory. When you encounter an error in a library you've never used before, the search for a solution can be a frustrating journey through outdated Stack Overflow threads, irrelevant GitHub issues. By providing the error message and your code context to a modern AI, you can often get a highly relevant explanation and a potential fix tailored to your specific situation. For example, getting a complex configuration error from a tool like Kubernetes can be instantly demystified when an AI not only explains what the error means, but also points to the exact line in your YML file that needs to be corrected. Section 5, your first step. Implementing the 80-20 of AI. We have explored high-leverage tactics, but knowledge without action is useless. The path to hyper-efficiency isn't mastering every hack, it's implementing one. Don't overhaul your workflow overnight. That leads to overwhelm and failure. Apply the 80-20 principle. Identify the single biggest time waster, target it with one specific AI tool. Get a small, immediate win that proves the approach. That win creates momentum to add the next hack. Let's recap the core strategies. Automating the mundane documentation, debugging test generation, augmenting the creative process, brainstorm designs, sketch diagrams, instant code reviews, accelerating knowledge acquisition. These are levers to reclaim time and amplify output.